Okay, guys, so we're having a little technical difficulty again with this laptop and the iPad being able to record the videos, so I can't actually show the PowerPoint now. Something I think in the internet here at where I'm staying is not allowing me to connect the two together, so I'm just going to look at the PowerPoints while I'm talking to y'all about it, pull out the important stuff. If you need to, you might want to go ahead and go print the PowerPoints right now so that you can look at them as I'm going through it as well. That is totally up to you. I'm going to tell you the important points. I'll write them down and we will make it through this one way or the other. Alright, so section 3.2 talks about logarithmic functions. So we're going to define log functions, evaluate them, derive basic properties of them. We're going to talk about their domains, we're going to graph them, and we're going to use natural logs and applications. So it tells us on the second slide there, for x is greater than 0 and a is greater than 0 and a is not equal to 1, that log base b of x is equal to y if and only if b to the y equals x. And we can go back and forth between them when we need to solve for whatever's missing. So this function, f of x equals log base b of x, is called the log function with base b. The log function is the inverse of the exponential functions that we talked about in 3.1. Now, I know the notes say log base a, but it doesn't matter what the base is. I know at other times we've used base b, so I'm just going to continue with that. Alright, so from there we go to the next slide. The third one there is example 1. In example 1, the directions tell us to write each exponential equation in log form. So we have example 1, and we're going to write it in log form. So a tells us 4 to the 3 equals 64. Guys, we're not solving anything. We're literally just writing it in log form. So remember, this is your b to the y equals x. So here's your b, here's your y, and here's your x. If you need to list them, do so. So b is 4, y is 3, and x is 64. And then we're just going to change it to log form. So you write out the word log base b, which is 4, of x, which is 64, equals y, which is 3. And there's our log form. b is going to be 1/2 raised to the x equals 1 over, I'm sorry, it's not raised to the x, it's raised to the 4 equals 1 over 16. So same idea. Here's your b to the y equals your x. List it if you need to. So your base is 1/2, your y is 4, and your x is 1 over 16. And then write it in log form. So literally write out the word log base b, so little 1/2 there, of x, so the 1 over 16 equals y, which is 4. And there's our log form for it. And then c, let's write it down here, says a to the negative 2 equals 7. Well, again, we're going to put it in log form. So this is my b to the y equals x. So my b is going to be the letter a, my y is negative 2, and my x is 7. So we're going to write it in log form. So log base b, which is the letter a, of x, which is 7, equals y, which is negative 2. Okay, so continuing on, we're going to look at example 2. And example 2 wants us to do the opposite. It says write each log equation in exponential form. So we're going to take the log form and we're going to go to exponential. So a is log base 3 of 243 equals 5. So remember, it's log base b of x equals y. So your base is 3, your x is 243, and your y is 5. So when you change it to exponential form, you have your b to the y equals your x. Okay. b is log base 2 of 5 equals x. And so we know it's log base b of x equals our y. So our b is 2, our x is 5, and our y is the letter x. So when we go to do an exponential form, it's b, which is 2, to the y, which is x, equals x, which is 5. And that's our exponential form. And then c tells us log base a of n equals x. So remember, it's log base b of x equals y. So our b is going to be the letter a, our x is the letter n, and our y is the letter x. So when you change an exponential form, be careful. You have b, which is a, to the y, which is x, equals x, which is the letter n. And there's your exponential form for those three. Alright, so as we keep going, in example 3 now, it wants us to evaluate the logs. So it wants us to actually find the value of them. So, example 3, a is log base 5 of 25. Well, remember, I'm going to write this up here by example 3, that we know if we have log base b of x is equal to y, and b to the y equals x. So what my rule is, if it says log, then you need to set it equal to the letter y. If it's an exponential form and it doesn't have an equal sign, then you set it equal to the letter x. And that way you're just staying consistent and it's not as confusing because you have letters in the place of other variables, like we had on a couple of the last ones. Alright, so when we go through here, we need to solve for y, and we're not going to use our calculator. So we know this is log base b of x equals our y. So we know our base is 5, our x is 25, and our y is the letter y. So I'm going to change this to exponential form. Anytime, guys, you get stuck in one form, change it to the other form to solve it. So I can't solve it in this form, so I'm going to go to exponential. So I have my b, to the, which is 5, to the y, which is y, equals x, which is 25. Well, we saw in exponentials we could get like bases. So 5 and 25 both have a base of 5. So I'm going to keep my 5 to the y, and we know 25 is 5 to the 2. Well, that one-to-one property we talked about says if our bases are equal, we can get rid of them, and therefore our exponents have to be equal. Therefore, y has to equal 2, which means log base 5 of 25 equals 2. And then we go on to b. b says log base 2 of 16. Well, we're solving for that, so it's in log form, so we're going to set it equal to y. And so we know our base is 2, our x is 16, and our y is y. Just knowing it's log base b of x equals y. And so we're going to change it to exponential form. So b to the y equals our x. Well, 16 I can bring down to a base of 2, so I'm going to bring down my 2 to the y, and 16 is 2 to the 4th. The one-to-one property says don't worry about the bases because they're equal. Therefore, the exponents have to be equal. So we know that log base 2 of 16 is equal to 4. Alright, so C is log base 1/3 of 9. Well, again, it's in log form. We're trying to solve for it, so we're going to set it equal to y. So I know my base is 1/3, my x is 9, and my y is going to be y. So I'm going to set it up in exponential. I'm going to change colors here. So we got our b to the y equals our x. Well, we don't like fractions, so we're going to change that 1/3. Well, I need to bring that 3 up. So remember, when you bring it up, it makes it a negative exponent anytime you cross that divide sign. So 1/3 is the same as 3 to the negative 1. I still have my to the y equals, but I know I want to get like bases, and I know I can take a 9 down to a base 3 because it's 3 squared. Well, then we have that power to a power that we talked about in 3.1. We're going to multiply the powers. So 3 to the negative y equals 3 squared. One-to-one property says my bases are equal, so I can get rid of them. And I'm just going to bring this up here now. And so I know that negative y has to equal 2. And so I divide by the negative 1. And I know y equals negative 2. Which means log base 1/3 of 9 is equal to negative 2. And let's see, we're on D. So D says log base 7 of 7. And when it's in log form, so we're going to set it equal to y. So my base is 7, my x is 7, and my y is y. So I can't solve it like it is, so I'm going to go to exponential. So b to the y equals x. Well, remember, 7 by itself there on the right has an exponent of a 1 written there. So the 1-to-1 property says our base is already equal, so y equals 1. And some of y'all may have had that memorized because some of your teachers in the past had y'all memorize those. It's not something that I make my students memorize because, as you can see, we can just work it out. But that is totally up to you, of course. All right, so we still have E and F that we're going to look at, but I'm out of room on this, so I'm going to have to clear this. So if you need to, pause it so you can go ahead and write it, but I'm going to clear what's on here. All right, so we're still on example 3, and we're continuing. So we're looking at letter E, and letter E says log base 6 of 1 equals, and we're trying to solve for it, so we're going to put a y there. So now my base is 6, my x is 1, and my y is y. So b to the y equals x. Well, 6 and 1, I can't get like bases, but this is one of those you just really need to know. I don't know any other way to explain it than you're just going to have to memorize it. Because what exponent can anything be raised to that our answer is always 1? Anytime the answer is 1, your exponent has to be a 0. And finally, F. So we have log base 4 of 1/2. And we're going to set that equal to y. So our base is 4, our x is 1/2, and our y is going to be y. So when I set it up into exponential form, I have b to the y equals our x. Well, this looks a lot like what we did on letter C now. So I need to get like bases. So first thing I'm going to deal with is fraction. And remember, to bring that 2 up, we're going to change the sign of its exponent. So it makes it a -1. But then I know this 4, I can bring that down to a base of 2. So that's 2 squared. And I still have to the y. Well, then power to a power says multiply them. So 2 to the 2y equals 2 to the -1. 1-to-1 property. So 2y equals -1. Divide both sides by 2. And we know that y is equal to -1/2. Therefore, log base 4 of 1/2 is equal to -1/2. Alright, so this is going to be the end of video 1. And we'll start on video 2 next.